Hello, going to be dealing with electrostatics again. However, this time we're going to be looking at it in a two-dimensional aspect. Right, so you can see already this is not on just one line now. It is, you can see I've got a left and right and a top and bottom one over here. So the points of P, R, and S are in the corners at right angles of a triangle as shown in the this diagram over there. So you can see if I have to connect these all together, let's use a different color. If I have to connect these, let's go with yellow. This is all going to be a right angle triangle. Okay, so as shown in this diagram below. Now they're going to ask us to calculate the force on S, right? Determine the electrostatic force on S, and then given all of these values over here. Right, so now because we've got the right angle, we can see, especially because Pythagoras only works with right angle triangles, we are going to be following Pythagoras. Now we're going to be doing the same thing that we have done before in terms of calculating which way it's going to be positive, which way is going to be negative, this and that. But however, now we know that just like in the last one, we can see that my charges are going to be moving to the left as well as to the top, from bottom to top. That's because of which one is negative and which one is positive. So I'm going to start off by saying S and P over here. So this one is charge 1, right? Well, this is my first radius, my first distance is R1 over there. So let's go with my force. I'm going to say, my force for, let's go, P on S is equal to K, Q, let's go with QS, times your QP, and this is all going to be over R squared, right? Let's add that together. Q we know is going to be 9 times 10 to the power of 9. My charge of S is going to be 8 times 10 to the power of negative 6. No, it's negative 6 because of my microcoulombs. And then I've got 4 over here times 10 to the power of negative 6. This is all going to be over 30 millimeters, but we know that there is 1,000, so it's going to be 1,000 millimeters in a meter, so it's going to be to the power of 3 times 2. I put it into my calculator and I should get an overall answer of, 320 newtons, and this is going to be upward. Right, we know it's upward because it's going from the positive to the negative over there. 320 newtons upwards towards P. Then I do the same thing for my other one over here, where it's going from my R to my S. So from my R to my S, oh sorry, the wrong direction. It's going from my S to my R over there. But it's all my forces acting on S because that is the middle point over there. So now I'm going to say F, my force again, F is equal to, let's go with R and S, K QR times QS over R squared. It's going to be 9 times 10 to the power of 9. QR is 6, so 6 times 10 to the power of negative 6. And then S is 8, so it's 8 times 10 to the power of negative 6 as well. And this is all going to be, here it's a 60 millimeters, so it's going to be 60 times 10 to the power of negative 6, the negative 3, negative 3 to the power of 2. Put that into my calculator and I'm going to get an answer of 120 newtons left. or you can say towards R. It's up to you which one you want to say, towards R or left. But now I've got my two directions. So you can see if I have to draw my free body diagram, it's going to look like this and like that, with my charges going outwards like this, and then an overall net charge, which I'm now trying to collect over here, which is going in this direction over here. Also, I don't know what my theta is going to be. Okay, and that is the issue. So now that I've got these two values, my 320, I've got this value over here, my 320 upwards, and my 120 newtons to the left. I will now use Pythagoras to calculate my net, my overall electro charge over there, my electrostatic force, right? That is going to be, so I keep on saying electrocharge, my electrostatic force, that is going to be my net, right? And I'm going to use Pythagoras to calculate that over there. And you should all already remember Pythagoras from grade 8 and 9. Right, so for my Pythagoras, let's use black again. I'm going to say here, my F net is going to be now 320. This is going to be squared, plus over here my 120, and that is also going to be squared, right? Yeah, and this is all square rooted. Okay, to calculate that, I'm going to get a final answer of 341,76 newtons, and that. But if they ask you now, what is the angle that it's going to be as well, you need to calculate the angle. So let's calculate the angle. Remember, I've got my opposite and my adjacent, right? I've got my two angles here. I don't have my hypotenuse, so I'm going to say tan theta is equal to, over here, what was my first one here? We can see it's 320, so I'm going to say 320 divided by 120. And then if you know how to use your calculator, your scientific calculator, click shift, then tan, so then it looks like this. Tan to the -1 is equal to 320 divided by my 120, which is 8/3. 8/3, and then you'll get an answer of your theta being 69. Let's see, shift 10. (69,44). 69,44 degrees. So now not only do we have my net, which is this over here, we know the net, we also know what angle of inclination it's going to be. It is at 69.44. And that is how we are going to do your 2D electrostatic force. All right. Thank you very much.